This is Unit 2, Lesson 9, example number 2 of the subtraction postulate, subtraction property of equality. All that means is if we have two values that are equal, so say 100 and 100, and I subtract an equal value from both of those, say 20 and 20, well, 100 minus 20 is 80, and 100 minus 20 is 80, so those two resulting values after I subtract equal things from them are still equal. That's what the subtraction property of equality states. So let's do another example. Remember, we cannot use the fact that we are going to prove in the proof. So we're going to show that vertical angles are congruent, and we're going to show basically that angle W is congruent to angle Y. So we have our statements and reasons table. I'm going to put angle W is congruent to angle Y in the last step, because that is what I am trying to prove. Given information, they didn't give us anything in particular, so I'd like you to pause the video, take 30 seconds, write what you know about this diagram, but remember you cannot use vertical angles are congruent to one another in the proof itself until the last statement, because that is what you are trying to prove or show. So I've written down what it is I know before I begin the proof. You can do this for any proof, even if there's not a space provided for you specifically for that reason. Try to write down what you know, because often proofs are complicated. There's a lot of different ways to do them, and so if you write down what it is you see, what it is you observe, what facts you know, it is easier to assemble the proof together. So right off the bat, I see that angle W and angle X are a linear pair. And I see that angle Y and angle X are a linear pair. How do I know that? Definition of what a linear pair is. So notice we're right back to that grouping of statements that we talked about in Lesson 6. Okay, what do I know about linear pairs? Again, remember, the proof has to follow logically from what you state. So I stated that they're linear pairs. I need to use that information to keep going forward with the proof. So angle W and angle X are supplementary. As well as angle Y and angle X are supplementary angles. How do I know that? Linear pairs form supplementary angles. Linear pairs are supplementary. That's how I know. I know that that is the definite part of the property of a linear pair. So what does supplementary mean? Again, each step is following from the previous step. I know that that means that angle W plus angle X equals 180 degrees. And I know that that means angle Y plus angle X equals 180 degrees. And that is the definition of supplementary angles. Or you can write supplementary angles to have a sum of 180 degrees. That's up to you which one you want to write. So now that I have two equations, one equals 180, another equals 180, I can replace one of those 180 with the equation equivalent. So angle W plus angle X equals angle Y plus angle X. So I replace the 180 with the equations because 180 is equal to 180, and that's substitution. When you replace a term with another term of equal value. So before I can prove that angle W is congruent to angle Y, I can see that angle X is going to be congruent to itself or equal to itself on both sides. So angle X is equal to angle X, or congruent to angle X. So that means that that is the reflexive property. So notice we have not used the subtraction property of equality yet. That is going to be our last step. Why? Well, if I subtract angle X from both sides in step 4, and angle X is congruent to itself, and I knew that angle W plus angle X is 180, angle Y plus angle X is 180, so these two quantities in angle 4 that I set equal to each other are equal, and I subtracted an equal thing, which is angle X, from both sides, the results have to be equal. So that's subtraction. property of equality, and again I'm just going to write subtraction. And notice that I had equal signs above, and now I have a congruency sign. I'm going to say angles that are equal in measure are congruent. Just to explain why I switched notation from equality to congruency.